Hello and welcome. Today, we're diving into something called Codifico AI, a program that's all about engineering the future of the autonomous industry. So let's kick things off with a really big question, one that's at the heart of the next industrial revolution. How do we actually teach a factory to think? This isn't about the old school repetitive robots anymore. This is the real challenge of what we call Industry 5.0, where physical machines and seriously advanced adaptive AI finally come together. And the answer really is a totally new way of learning. That's where Codificato AI comes in. It's this massive 2,000-hour postgraduate program, and it's been built from the ground up for one specific purpose: to bridge the gap between traditional, hardcore industrial control and the wild frontier of agentic AI. But look, before you can build the future, you have to be an expert in the present. So the whole program starts right at the bedrock of industrial automation. It's all about getting students grounded in decades of proven, solid engineering, the deterministic world of precise, predictable control. This means getting your hands dirty with the core stuff. We're talking about programming the brains of most factory machines, the industry standard PLCs. It means really getting the deep theory behind things like PID control for that perfect precision, and then tying it all together with SCADA systems for a bird's eye view of the whole plant. Honestly, mastering these predictable rule-based systems, it's the absolute non-negotiable starting point for everything else. And this slide right here, this shows you the huge shift in thinking. Traditional automation is kind of like a train on a track, right? It follows one fixed, pre-programmed path, and that's it. But agentic automation, which is where this whole course is heading, that's more like a self-driving car. It has a destination, a goal, but it's constantly adapting its route based on a live flood of data from the world around it. Okay, so let's move from those classic centralized controllers to the real game changer, putting powerful distributed intelligence right on site. We're essentially giving the factory an on-site AI, right where the action is happening. And we do that with something called edge computing. Now, why is this so important at a factory? Well, because when you have machines moving at high speeds, every single millisecond counts. You just can't afford the delay, that latency, of sending data all the way to a cloud server and waiting for a response. Processing your AI models locally, right at the edge, is the only way to get the real-time performance and rock-solid security that modern industry absolutely demands. Now, to make that happen, you need some serious firepower. The course is built around this core piece of hardware, the NVIDIA Jetson Orin Nano. It can pull off 67 times trillion operations per second. And just to put that in perspective for you, this isn't a small upgrade, it's a massive leap in power that lets you run these incredibly complex, heavy-duty AI models right there on the factory floor, no cloud required. So what does all that power actually let you do? Well, here's what it enables in the real world. We're talking about real-time computer vision using top-tier models, running that agentic AI locally, and even executing custom code for super specialized tasks. For instance, a key project in the course uses this power to visually identify products on a fast-moving conveyor belt in less than 10 milliseconds. That kind of speed is just incredible. Right, but think about it. An intelligent system is completely worthless if you can't trust it. So the next major pillar of the course is all about the non-negotiable standards for building systems that are robust, reliable, and of course, secure. First up, there's functional safety. This is covered by a standard called ISO 13849. To put it simply, this is all about making sure the machine fails safely. If something goes wrong, the number one priority is to prevent anyone from getting hurt. It's about protecting human life, full stop. The other side of that coin is industrial cybersecurity, which falls under the IEC 62443 standard. Now, this is about protecting the system from hackers, from intentional malicious attacks. In today's hyper-connected world, this isn't just a nice-to-have, it's absolutely essential to prevent sabotage or data theft. Okay, so when you see it laid out like this, the crucial point becomes really clear. One standard is all about preventing accidental harm, the other is about stopping intentional attacks. Codifico AI teaches you how to weave these two together from the very beginning. And that's the really tricky part, right? Figuring out how to apply these rigid, deterministic safety rules to these new, non-deterministic AI systems that learn and adapt. That's the new frontier. And that brings us to the really exciting part, the agentic robotics frontier. This is where all those pieces, the industrial control, the edge AI, the trust and safety, it all comes together to create truly intelligent, physical AI. We're turning code into real-world action. This quote here, it just perfectly captures the goal. We're moving beyond just creating systems that can see and understand language. The real aim is to build an embodied brain, a robot that has a kind of physical common sense and can actually understand and operate in the world. And the tech that makes this a reality is the Vision Language Action Model, or VLA. This is the magic that lets a robot look at a scene, understand a simple command like, hey, pick up the red block, and then translate that into the precise sequence of movements to actually do it. And the whole course builds up to this absolutely incredible capstone project, implementing a cutting-edge VLA model on a state-of-the-art platform, the Unitree G1 humanoid robot. So you're not just talking about theory, you're applying it to one of the most advanced robots out there. And look, this shows you it's not just a hypothetical. Students go through the entire end-to-end process themselves. They start with the raw data, they configure and fine-tune the AI model for specific jobs, and then they deploy that final unified policy right onto the robot. It takes them all the way from a line of code to a fully functioning, task-driven humanoid robot.
So what's the end result of all this? Well, when you bring all these different worlds together, industrial control, edge AI, safety, security, and advanced robotics, you don't just get a new skill, you forge an entirely new kind of professional.
And here's the real takeaway. A graduate from this program has this uniquely integrated skill set. They can speak the old school language of the factory floor and deploy the latest high-performance AI. They can build systems that aren't just smart, but are verifiably safe and secure. And they can bring it all to life by implementing these advanced VLA models on robots, managing the whole ecosystem from start to finish. And that leaves us with one last big question to think about. When you have systems that can see, understand, and act with this level of sophistication, are we just building better tools? Or are we actually engineering the very first generation of true industrial collaborators? For more on the future of AI and robotics, make sure you subscribe at News AI TV. Thanks for joining me.